Alright, so today we are going to start with Unit 5 of Digital SAT Prep. All of you who don't know what it is, there's on Khan Academy, if you go to, there's a section called Test Prep. Inside that you will find something called Digital SAT Prep, where you have total 13 units. That is going to be the entire scope of, hi Ananya. That is going to be entire scope of what would be asked in SAT exam. So we are going unit by unit. We have done till unit 4. We are starting with unit 5. That doesn't mean kids who have joined in between, they would be missing those units that are done. We are going to again repeat the cycle. Okay. So right now we are starting with unit 5 and then we'll continue till unit 13 and then again go back to unit 1. So that way we'll do more and more practice because math is all about practice. Only thing is second iteration when we do, a lot of concepts will be known to us so that we would be able to go a little faster. Okay, and we'll focus more on tricky questions and all. And for you all, my request would be make sure that when we do attend the class, we learn some concepts. You do the unit test in Khan Academy because that's the only way you can ensure that what we have learned is actually useful enough. Yeah, I have not seen anybody sending me the confirmation like you guys used to send before, saying did the unit test for this one. But let's keep it disciplined so that way at least you would also know that okay, yes, I have done my piece, or at least if there's something that is missing or something that is taught in the class but that is not helpful enough, you would know that okay, sir, you did not teach us this thing and we are getting stuck, right? So the assignment is not as a brutal force for you guys to do it, but more of a thing for us to ensure that whatever we are learning, that is useful enough. Alright, so let's start. And for Neil and Sarah, is the speed at which I talk okay for you guys, or am I talking way too fast, way too slow? How's it?
It's good.
It's good? Okay, alright. So let's continue then. Now, as you guys know, I'm a very old guy. I keep forgetting things. So, on a lighter note, let's look at what are the topics that we have to cover as part of this unit. So we are going to talk about area and volume of different shapes. We'll touch upon the congruence, similarity and angles related stuff. Then we'll talk about triangles and parallel lines, and then if time permits we'll go to trigonometry basics, and then we'll continue tomorrow as well. So let's start with the area and volume. So I'll try going very fast because I know you all have decent understanding of different shapes and their area and volume stuff, but I will keep on pausing in between, keep on asking you guys to see, just to make sure that everybody in the class is on the same page. So let me know if I would need to stop anywhere. Okay. All right. So okay. Starting with the basics. Everybody knows area. Very practically, if I talk about area, it's the space taken by that object on that surface. This has more area, less area, little area, almost negligible area. Whatever you see on the board, this depicts the area. So there are different shapes and there are different ways to calculate the area. There are different formulas. Some of the formulas I have already proven in the previous classes, and whenever you guys have a question, say okay, how did you say that this is the right formula for the area? We'll do a double click on that. So let's start with the different shapes. Let's start with the area starts, or you start talking about area only for the closed shapes. You don't talk about area of a parallel line. Everybody with me, right? You talk about area of closed shapes only. So the first thing that you start with is a triangle. Now, let's look at the triangle. There are different types of triangles, you all know. It could be equilateral triangle, isosceles triangle, scalene triangle, right angle triangle, whatnot. There are different types of triangles. So, what is the area of a triangle? Everybody knows, or you guys have any doubt? What is the formula for area of a triangle? Yes, Arya.
1/2 base times height.
Base times height. So again, I'll keep on giving very stupid examples, but just bear with me. If you say half into base times height, what does it mean? If you take this as a base, then we're talking about height as this. If you flip this triangle and make this as a base, then from here to here this is your height. If you flip it again and take this as a base, then here to here is your height. So remember this, there is no side that is defined as a base. The base is the side that is lying on the on which this shape is based. Okay. So if I am drawing a triangle like this, and I say this is my base, this is where I am keeping it, then this becomes your base, and here to here this height is your height. So there is no side that is defined as a base or a height. It's a way you look at it. It's the way you visualize that shape. If you call this as a base, from here to here, whatever is the height, that will be your height. This will be your base, this will be your height. Regardless of which one you are taking as a base, the opposite the vertex to that side, whatever is the perpendicular distance, that is your height. That's how you have to look at it. I'm sure everybody knows it that way. I'm just being redundant to make sure that we are not misinterpreting anything. Are you guys with me so far? Everybody?
Yes, sir.
Yeah.
Yeah? So there will be a lot of questions coming to Sarah and Neil, because this is your first class. Everybody else in the class has spent some time with me, so I know when they have a doubt how they react. When they don't have doubt, how do they react? Since for you guys it's the first class, I will ask a couple of questions to you both, but don't think that I'm trying to put you guys on the spot. It's only my mechanism to make sure that I'm effectively teaching everybody in the class, okay? Alright, so this is on the triangle thing. So half into base into height. Now you will say, how is that formula derived? We can derive that when we talk about congruence. I will even prove that formula, okay? So let's go to the next thing. So when you talk about any other triangle, you say base times height, and that formula applies for any and every triangle. When you look at a right angle triangle, here you will say this is my base, this is my height. The good thing with the right angle triangle is one of the side is the height, because it's perpendicular, right? Height is nothing but the perpendicular distance. If I talk about this triangle and say base times height, height is nothing but the perpendicular distance from the vertex to this side. Okay, so here in this case, the vertex is this one, the perpendicular distance is this one. So that is how, in this case, you have a base and a height defined. So the same formula applies here also, half times base times height. In case of right angle triangle, you have two sides, one is a base, one is a height. You can pick this as a base, this becomes your height. You pick this as a base, this becomes your height. But in case of any other triangle, you'll have to derive that perpendicular distance, or find out what is the height basically. I mean, either you'll be given or you have to find it out, any which way. But in case of right angle triangle, that is given to you. You don't really have to calculate. Okay? So this part is fine. Triangle, we double click, triple click 4 times, we can move on. Now we are talking about a quadrilateral. Oops. So when you say quadrilateral, how many types of quadrilaterals you guys are aware of? How many types? What are the different types of quadrilaterals that you guys can recall or call it out? Yeah, Arya, tell me 2 of them, except rectangle and square.
Parallelogram and trapezoid.
Okay, Praneeth.
Kite and rhombus.
Kite and rhombus. Okay. What else? So we heard, I excluded two of them already, said excluding rectangle and square. So kite and rhombus, parallelogram and trapezoid. So let's look at the formula for area of all these shapes. And again, I'm not trying to prove the formula for these areas because you guys already know about it and you have dealt with it enough, but there could be some scenarios where you would want to know why it is so. We will come back to that and we'll try proving it. So let's look at, and again, I'm just doing a quick recap of all that you guys know. So that we are compliant with the topics for the unit, and then we'll go on practicing more. So now look at the different shapes. So I said exclude rectangle and square. So these two I asked you guys to exclude. Then you said rhombus. Then you said kite. Then you said trapezoid. Then you said parallelogram. Okay? These are all quadrilaterals that we are aware of. Rectangle, I will not even talk about it. Area of rectangle is length times width. Everybody knows. No doubt. Square is also a sibling of rectangle. So here also area is length times width. Beauty of this problem is length and width are the same. So that's why it becomes length square. If you talk about rhombus, this is where the fun begins. Area of a rhombus. Who can tell me how much it will be? Okay, let me first help you guys recall. A rhombus is nothing but a squeezed version of a square. Meaning if you have a square and you put two corners in your hand and squeeze it. So it becomes thinner and larger. So you had a square like this, let's say. This was your square. What you did? You applied force here and here, and that led to this becoming thinner and longer. So, as you would remember, rhombus also has all four sides of the same length, like a square. Only difference between a rhombus and a square is square has all angles 90 degree. This became smaller than 90, this became bigger than 90. Right? So now you have a rhombus. How do you determine the area of a rhombus? Anybody remember the formula? Okay. It is half. So basically in rhombus what you do is, let's say this is a rhombus, A, B, C, D, or A, B, C, D. What you do is you join the two opposite vertices and you call these two as diagonals. So area of a rhombus is half times diagonal 1 into diagonal 2. Half times diagonal 1 times diagonal 2. Does anybody in the class remember this formula, or I'm forcing you guys to remember this?
I remember it, sir.
You remember it? But if I ask, how did that come into existence? Does anybody know? Okay, we'll do it real quick, okay? Real quick. So, I'll try proving this formula, okay? Every day, you guys can challenge me, say, okay, sir, prove one of the formulas, okay? And I can do it. So, I will prove this formula. Let's look at the area of a trapezoid. Does anybody know? Okay, first of all, the property of a trapezoid. The trapezoid has one unique behavior or property which says a trapezoid is a quadrilateral which has only one pair of lines parallel to each other. only one pair of lines parallel to each other. That's it. And they're not same, they're just parallel. Now, so let's say side A and side B, these two are parallel. What does a parallel line mean? And guys, even if I ask stupid questions, just bear with me, okay? If I say, what does a parallel line mean? What does a pair of parallel line mean? Yes, Arya.
A pair of lines that never touch each other.
That never touch each other, and if we want to add some more color to it, we'll say the perpendicular distance between the two parallel lines will remain the same throughout, regardless of how far you go. Yeah? Meaning, if these two lines are parallel, so the perpendicular distance between the two lines will remain the same. Even if you keep on extending it, if you go here, the distance will remain the same. Like a railway track, yeah? The distance between them will never change. It will remain the same. Yeah? So now, tell me, what is the area of a parallel trapezoid or trapezium, whatever you call it? Yep. Yeah.
Is it base 1 plus base 2 over 2?
It's base 1, or let's say if I call them A and B, A plus B over 2, and you are missing one thing, which is height. Height is nothing but the parallel distance between the perpendicular distance between the two parallel lines. So area of a trapezoid is half into height, the distance between the parallel lines, multiplied by the sum of the two parallel lines. So the two sides that are parallel, add the length of those two sides, divide that by 2, and then multiply that by the height or the distance between the two. Now you will ask me, how did this come into existence? We'll prove this also. Make sense? So we'll prove the area of a rhombus as half into d1 into d2, and we'll prove how come the area of a trapezoid is half multiplied by height multiplied by a plus b. Is that okay?
Yes, sir.
Now, same thing with the kite. Do you guys know what is the area of a kite? Do you know what is the property of a kite? See, in the rhombus, what did we see was all the four sides are of same length and the angles are not 90 degree. Another property that we found was, we have not talked about that property. We'll talk about it when I try proving it. Okay. Kite's property is only these two sides are equal to each other. This side and this side are equal to it. So there are two pairs of lines or sides which are equal to each other. Okay. It's the same kite that we fly, right? I mean, I'm not sure if all of us have got a chance to fly, but luckily when I was of your age, I had the privilege of flying kites back in India. Here I have not seen people flying kites, but yeah. It was linked with one of the festivals also. So that's where we used to get a chance. So kite's main property is, it's also a quadrilateral, four sides, but the sides are equal in pairs. So the top two sides are equal to each other, bottom two sides are equal to each other. Yeah? Same thing, area of a kite is also, if you join the opposite corners and call them diagonals, area of a kite will be equal to half into, let's say this is D1 and this is D2, D1 into D2. Okay? Yeah? So this area of a kite and area of a rhombus follow the same formula. So what we'll do is, I will prove how this area formula for this area came into existence. I will also prove how this area formula came into existence, and I'll let you guys prove this one by yourself as an assignment for it. Okay? It's about relating the concepts and using that to ensure that you understand how any formula works or comes into existence. Otherwise, it will be like a monologue where I'll give you guys 10 formulas, memorize it, mug it up, and then just keep applying it everywhere. No, math, I don't believe in teaching math that way. I would always enforce or emphasize on the fact that I will tell you a formula. I will also try finding out how to prove or how to know how did that formula came into existence, and then you can apply that formula as if that is your formula, right? So let's look at these two. Now comes the area of parallelogram. Area of a parallelogram is, who all remembers the formula for area of parallelogram? Babu. Babu, you were saying something? Area of parallelogram. Okay, what is the property of a parallelogram? What do you call a parallelogram? Or why do you call something as a parallelogram? Yes, Arya.
I was just gonna tell you why it's called a parallelogram.
Yes, please go ahead.
So the lines opposite from each other are parallel. So the lines like on the top and bottom are parallel from each other, and the lines on the left and right are parallel from each other.
That's a good definition. Now there's an opportunity for everybody else, including me. Is there one more aspect of a parallelogram that Arya did not mention, which is a property of parallelogram? And Arya doesn't have the chance now. Let's see if I can wake up everybody. Whoever is
Sir?
yes.
Sir, I think the area of parallelogram is the same thing as rhombus. No, right?
No. My question was different. See again. Yep.
The angles are not all 90 degrees.
I'm sorry.
The angles are not all 90 degrees there.
Angles are not necessary. See, one input that I got here was that in the case of parallelogram, the angles are not 90 degree. That is partly correct. Angles may or may not be 90 degree. What I mean by that is, if I have a rectangle, this is a parallelogram, because the opposite sides are parallel to each other. There also. And so one more property, Arya, that you missed, I'm sure you know it, that parallelograms, other property is the opposite sides are parallel and equal to each other as well. Okay?
Yeah, I knew that.
Yeah. So, I mean, that's very important. That's why I'm kind of calling it out. So, main property is the opposite sides are parallel and equal to each other. Now, if you compare a parallelogram with a rectangle, rectangle says that my opposite sides are parallel and equal and every angle is 90 degrees. So, they are very strict about that property. Wherein parallelogram is flexible. It says my opposite sides are parallel and equal to each other. They may or may not be 90 degrees. That's the flexibility parallelogram offers. So you can always assume this as parallelogram is your superset and rectangle is a subset underneath. Make sense, everybody?
Yes, sir.
Here, Shravya, Ananya, everybody, Vaibhav, Sivatsa, yeah. Neil, Shara as well? Yeah, okay. Alright, so, and you guys have Dhanusri, everybody with me, right?
Yes, sir.
Okay. There will be a lot of things that will be known to you as well. But math doesn't tell us that we will not learn something that we have learned in the past. Okay? So it's like a revision for you guys. Alright. Now, so we looked at, we know the property of a parallelogram. So parallelogram says that the opposite sides are equal and parallel. That's the most important thing. And the angles may or may not be 90 degrees. That's the flexibility this guy offers. This is more generous quadrilateral compared to rectangle. Rectangle also says my opposite sides are parallel and equal, but don't dare to call me a rectangle if the angles are not 90 degrees. This guy doesn't say so. That's the difference. Okay? Now, what is the area of a parallelogram? Who remembers?
So is it base times height?
Yes, it is. Always imagine a parallelogram or a rectangle as twice of a triangle. Look at this. If I join the two opposite corners, always imagine, okay? This is one of the most stupid example that any teacher would give, but I'm just trying to help you guys memorize this in an easier way. You will never forget the area of a triangle is half times base times height. Everybody knows that, right? When I asked that formula, everybody knew that. Always imagine a parallelogram or a rectangle as 2 times of the triangle. Look at this parallelogram. I just joined the two opposite corners, it split that into 2 equal triangles. I mean, at least visually. Mathematically, we have not proven that yet, but visually I'm saying. So, if the area of a triangle is half times base times height, my area of parallelogram would be 2 times the area of a triangle. To 2. These two gets knocked off. Base times height. Same way here. Look at this. This is a right angle triangle, 2 times. If the area of this triangle will be half times base. Base is this length and this height is width. 2 times of this area. Multiply this by 2. See? Length times width. So always visualize that. Math is, my definition of math is, it's a subject that you see every day around yourself. Be it math, be it physics, be it chemistry, right? All the science and math subjects, which I'm fond of, because I see it every day around myself. So, any concept that you learn, you relate, you see, you experience, you witness, rather than just not doing it on a piece of paper. Okay? I hope that's not an overdose of theory. Okay, alright. So coming back to this one. So we saw the area of a rectangle as length times width, area of a square is length times length, because length and width are same. Area of a rhombus, I forced you guys to memorize that this is half times diagonal 1 times diagonal 2. Same way I said for kite also, it's half times diagonal 1 diagonal 2. This will be your assignment, this one I will prove today. And then I said area of a trapezoid is half times height between the two parallel lines multiplied by sum of the two parallel lines. Now this one also will prove. And then area of parallelogram is base times height. If you take this as a base, this is the height. If you take this as a base, this is the height. Okay? So far, no problem, right? Everybody with me?
Yes, sir.
Okay.
Yes, sir.
Okay.
Sir.
Sarah, Neil?
Yes, sir.
Okay. You guys able to catch up with the way I'm explaining things, right?
Yeah.
Okay, wonderful. Shravya, you are with me so far?
Yes.
Okay, wonderful. So some of the names I might have missed, but when I ask few names, the intent is to make sure that everybody is with me, okay? You guys have no choice to take away the next 1 hour out of this thing. I mean, this next 1 hour is only for me, okay? That's how I want your attention. Alright, so I said, if this is a rhombus, then the area of a rhombus is half into, this is D1 and this is D2. D1 into D2. Okay? I can prove this. It's a 2-minute thing. But before I do so, I want to see who all is comfortable with the basic theorems of congruence. Do you guys know what is a congruence? What do you mean by congruence? Okay, Pranit knows.
Yes, sir.
Arya knows. Sarah, Neil, Dhanushree.
Yes, sir. Yes, sir.
Everybody knows what is congruence? Okay, congruence, simply put, congruence is, this is my hand, this is my second hand. If I overlay one hand over the other one, now if you see, it looks like one hand. If both my hands were of different sizes and bit deformed like this is how it would have looked. From this side it would have looked this, from this side it would have looked different. Yeah. So when you say congruence, in layman's term, two things are congruent, meaning they are exactly the same. And in geometry, when we say something are same, what we mean is each and every property is matching. Let's say if I ever dare to say that Biren and here are same, that means each and every property of mine is exactly matching with each and every property of here. Or Dhanushri and Arya are same, are congruent, meaning each and every property of both the kids are matching. Yeah. So I know here is feeling little offended now. I'm saying my property and his property are matching. He is way too young, I'm way too old now. But that was just an example, okay? Don't take it personally. Now coming back to a serious discussion. So when we say two things are congruent, they're exactly the same. Each and every property are matching. Are you guys with me so far?
Yes, sir.
Ananya, you agree with me?
Yes.
Some of you are not ready for the surprises, right? But that's my job, what to do. Okay, alright, I'll keep on calling out your names just to make sure that everybody is with me. Okay? Now, so there are 4 theorems of congruence. I will not go into detail proving that. However, I can prove it even when I'm half asleep. But there are 4 theorems. Who can tell me what is SSS? Yep.
Side. It follows 3 sides.
So, made a mistake. These are the 4 theorems for congruence of triangles. To be more explicit, SSS stands for side, meaning if there are 2 triangles with matching sides, 3 sides of one triangle being equal to 3 sides of the second triangle, they are congruent. And interesting part is, nobody can ever dare to prove this theorem, okay? Because this is a universal truth. If you are given one triangle with 3 dimensions of side 1, side 2 and side 3 given, you can draw only one type of triangle, no matter how many hours you spend. You can flip, you can rotate, but it will be the same triangle. Okay? So this is like a universal truth. You take a compass, draw a triangle, you are given, let's say, 3 sides as 3, 4, 7. Oh, this is not correct. This. And if I said, okay, 3 centimeter, 4 centimeter and 6 centimeter, draw 5 triangles matching with this, eventually you'll be able to draw only one triangle. Even if you draw 5 copies of it, they'll be all the same. Okay? You can do it for fun, okay? Try it again. But that's a universal truth. Okay? Now, so this is what the first theorem says. If 2 triangles have 3 sides matching, they are congruent, and you cannot deny it. Now, what does ASA mean? I'll come to you. Let's see. Anybody on the screen? What does okay, yeah, go ahead.
ASA stands for angle side angle.
Angle side angle. Okay, and by definition it says angle, this angle, the side and the angle, meaning the 2 angles and the side between them. However, I am giving you guys a flexibility, okay? It can be any 2 angles and one of the sides. That's also fine. Okay? The theorem says the 2 angles and the side between them. If I have 2 triangles where 2 angles, meaning this is 1, this is also equal to 1, if this is 2, this is also equal to 2, and the side here, these 2 are matching, then these 2 are congruent, meaning when I say congruent, then other sides will also match. But then what I'm telling you guys is, don't worry about this 2 angle and the side between them. I'm giving you the flexibility that it could be any 2 angle and one of the sides. Because in triangle, if 2 angles are matching, the third angle has to match any which way. right? Sum of all the three angles is 180 degrees. If two are matching, the third angle has to match. So whether it's the side between the two angles or this side doesn't really matter. Okay? Yes, Vaibhav.
Sir, so SAS is like two sides and one angle, right?
So see, there's a difference. Yes, SAS is two sides and one angle, but in case of SAS, it has to be two sides and the angle between them. So this side and the angle between them. You cannot say this side and this angle. Okay? So that's one basic difference between the ASA and SAS. In case of ASA, though it says the two angles and the side between them, but you can pick any two angle and any side. That's fine. But in case of SAS, it has to be two sides and only the angle between them. Alright?
Yes, sir.
And I am sure Dhanusri will not like me if I try proving these theorems here, okay? Because I've done it a couple of times and I will do it on a need basis, okay? Any day somebody says, okay sir, can you prove SAS? I'll prove that, okay? We'll do it on a need basis. I'm not trying to go into proving these theorems again today. Otherwise, two of the kids for sure will start hating me. One is Pranit, one is Dhanusri. They've heard enough from me, yeah? Okay, but yeah, for everybody else, whenever you guys want me to prove any of the theorem, I will do it. Okay? We'll pick up one theorem and we can prove it in a class. It just takes me 10 minutes. Alright? So,
Yes, sir.
coming back to these theorems, these four theorems are for congruence. First one says if there are two triangles where the three sides are matching, they are congruent, meaning the other properties will match. Other properties in a triangle are nothing but the angles. Yes, Ananya?
I have a question. Wait, are you basically teaching for SAT?
Yes.
Right? But this year it was ACT, and I feel like ACT math is like different than SAT because SAT goes like deeper into problems, and ACT is more about brain.
Right. So I'm teaching for SAT. So that is why I'm going more into. See, and again, let me think. How do I put it? I'm covering the concepts for SAT, and when I'm teaching for SAT, my primary objective is to make sure that I'm not giving you guys just a formula and say apply the formula, because that is what is given in the books also. So I'm not actually helping you guys build that concept around it. So that's why if I give you guys a formula, it's my job to explain how that formula came into existence so that becomes your concept. You're not relying on your memory to solve things. Tomorrow, if you are getting stuck somewhere, you know how to derive that quickly and then solve it also.
Okay.
Let me know, Ananya, if there is any concern. I mean, I can certainly tweak something which benefits you guys. But yeah, just curious. Okay. Alright. So these are the four theorems that we will use. Okay. Three sides matching, they are congruent. Two angles on one side matching, congruent. Two sides and the angle between them matching, congruent. This is RHS, this is for right angle triangle, where it says if it's a right angle triangle and hypotenuse and one of the side match, they are congruent. This is just a prelude before I try proving this one, okay? This is very important. So that's why I was touching on this one, these concepts. So the four theorems, right? So I'll just write it in a small font so that it doesn't bother us. ASA, SAS, RHS. RHS we did not touch upon much, but it says if there are two right angle triangles where the hypotenuse are of same length and one of the side is also of the same length, then they would be congruent. Okay? Meaning, again, it relates to the Pythagoras theorem, a square plus b square equals to c square. A and b are two sides and c is the hypotenuse. So if hypotenuse matches and one of the side matches, right, then third side has to match, correct? So that's what it says. So this one and this one is relatable. You can relate this, okay? So I just said if it's a right angle triangle, meaning it'll apply Pythagoras theorem, hypotenuse of the two triangles are same and one of the sides are also same, then the third side has to match any which way. So that is how this theorem came into existence. Everybody with me so far, right? Whatever I explained, I hope nothing is difficult to digest and process so far. If there is one, let me know. Vaibhav is fine. Neil, Sarah, Shravya, here. Dhanusri, I'm sure she's just waiting for me to teach something else. Yeah? Okay, Sivatsav, everybody, Ananya, everybody with me, right? Okay, let's move on. Now, I'm saying area of a rhombus is half times diagonal 1 times diagonal 2. Now, there is one more property that you guys need to understand. In a rhombus, like I said, rhombus's main property is all the four sides are of same length. Now, another thing that you can remember as a property is the diagonals of the rhombus bisect each other in a perpendicular way, or diagonals of a rhombus are perpendicular bisector of each other. Okay? Diagonals of a rhombus are perpendicular bisector. So perpendicular bisector has two words into it, perpendicular and bisector. Bisector means something that divides into two parts or equal part. Yeah? Bi-weekly, twice a week. Yeah? Bi-monthly, twice a month. Right? Same way, bisector, two sectors of equal length. Okay? So, diagonals of a rhombus are perpendicular bisector of each other, meaning they are perpendicular to each other, meaning they cut each other at 90 degrees and they divide each other into two equal parts. So this part is equal to this part is equal to this part. This is just the property, okay? So this is like we say a rectangle is a quadrilateral with four sides. Opposite sides are equal and parallel to each other and every angle is 90 degrees. Likewise, the property of a rhombus says that the diagonals of a rhombus are perpendicular bisectors, apart from the fact that the four sides are of same length. Is this property digestible so far?
Yes, sir.
Okay, here with me. Shravya with me.
Yes.
Okay. Now, yes, somebody raised hand. Who was it? Nobody? Okay. Alright. So here, what we know is, this is diagonal one. Let's say this is, let's give it a name. A, B, C, D. So first diagonal is, D1 is, let's say this one, BD. Okay, B to D. And second diagonal is A to C. D2 I am saying as A to C. And let's say they are meeting at point O. This is point O. Okay. Now, there are two things that we are going to mix. First in a property, now we know this side and this side are same. This part and this part are same. Okay. Meaning BO, okay, let me write it down. In this diagonal, BO here to here is equal to OD. Okay. Similarly, AO is equal to OC. So far it's clear, right? Everybody with me?
Yes, sir.
Okay. Now let's look at this triangle. This triangle and this triangle. Can I say they are congruent? Can I say this triangle? I am saying triangle AOB, meaning this part, okay, and triangle is congruent with triangle AOD. Can I say so? Yeah? Both are right angle triangle, right? As I said, they are perpendicular bisector. Okay? So this is 90 degree, this is 90 degree. So they are right angle triangle. Hypotenuse are same. So this one and this one are same because that's rhombus. And then this side is common. So hypotenuse and side is common. Any which way we know that okay, this and this are perpendicular bisector, right? So these two are same as well. So we know that okay, triangle AOB, this triangle and this triangle are congruent. That means their property will be the same and their area will also be the same. Okay. So if I have to just tell the area of the red part, I can say area of the red part will be equal to 2 times area of triangle, let's say AOB. Are you with me so far?
Yes,
Yeah.
sir.
Okay.
Yes, sir.
Similarly, if you look at I got a pink this thing for some of you to like. Okay. So now let's look at the pink part. I don't think this is pink. There could have been a better pink. Anyway, let's go to purple. So let's look at the area of the purple part. Again, same way. Look at this one. Triangle BOC and triangle COD. They are also congruent. Same way like we saw these two triangles, correct? Again the right angle triangle, this and this are same. This side is common, so they are same. So these two are also congruent. Yeah. So same way we can say the area of this purple part, okay, is equal to 2 times area of BOC. Are you guys with me so far?
Yes, sir.
Everybody, Vaibhav, Shivatsav, Savya, Heer, Dhanushri, Neil, Sarah, everybody, right? Okay.
Yes, sir.
Okay. So now, area of this part is 2 times area of this triangle and area of the bottom part is 2 times the area of one triangle. So now let's look at first area. This area is equal to 2 times area of this triangle. This triangle is what? Half into base into height. Now base is what? BO into height. Height is AO. Okay. So I will knock off these two. Okay. So it's BO multiplied by AO. Similarly, this area will be equal to half into base. So this is my base BO into height. This is OC. Okay. So I have got two area. Half. So this half into BO. What happened? Okay. Yeah. Half into this is the area of this. I multiplied this by 2. So these will get knocked off. So BO into AO, BO into OC. BO into AO and BO into AC. Okay. So here this is one area, this is one area. BO into AO is this area, BO into AC is this area, OC is this area. So total area for me is BO into AO here to here plus the bottom area which is BO into OC. Now look at this. Okay, now look at this. Here BO is common, so I'll take BO out. AO plus OC. AO plus OC. That means BO multiplied by AO plus OC. AO plus OC is what? Is my diagonal 1. Yeah? AO plus OC, this is my diagonal 1. Correct? Now BO is what? BO is this part which is nothing but half of diagonal 2 because they are bisecting each other. So this BO is equal to nothing but diagonal 2 divided by 2 multiplied by D1. This is what I was saying. Area of a rhombus is diagonal 1 multiplied by diagonal 2 divided by 2, or half times d1 into d2. Now just look at a summary of this. Summary of this is, I said area of a rhombus is half times d1 into d2. How did we prove it? We know the property of a rhombus is that the diagonals are perpendicular bisector of each other, meaning they meet here and make 90 degree, and they divide each other at 50-50. Then we looked at the theorem of congruence, proved these two triangles being congruent, these two triangles being congruent, and then we just find a place and sit down. Let me finish this class. So then we looked at the area of this one, multiplied that by 2, area of this one, multiplied that by 2, added it together. That's how this theorem got proved, or this formula got proved. Okay? Any questions so far?
No, sir.
So we looked at all the different quadrilaterals, we looked at their area formula, and then we tried proving how the formula for area of a rhombus is half times d1 into d2. Ishan, don't make any sound right now. Okay. So this is how we can prove this one. Now we have 5 more minutes, and I certainly don't want to drag this one to next class. That's why I just told you guys I would want to prove this area of a trapezoid. This is A1 and this is A and this is B, and the height between them is H. I said the area of a trapezoid is equal to half times height multiplied by sum of the two parallel lines. Now, don't make any sound. Yeah. The clue for that is this, okay? I'm just breaking it down for you guys. The clue is this. Draw a perpendicular line from here to opposite side. So now if you look at the trapezoid, you have 3 parts to it. One is this rectangle, okay? The one in the center. And then you have 2 triangles. This one and this one. Here, if you find out the area of this rectangle, then this is A times height, A times height. This is the area. Now this is one triangle and this is another triangle. Both are right angle triangle. Half times, let's say this is B1, this is, let's say B, this is A, and this is B2. So basically the total line, this length of this one is A plus B1 plus B2, and this together is B, the total length. Okay? So what we have to do is find out the area of this triangle, which will be half times height times B1, area of this one, which will be A times height, and the area of this will be half into B2 into height, and then we add these 3 together. That is what we will get. I'm just trying to go a little fast here, but let me do that. So my total area of a trapezoid is half this area, half into B1 into H, which is the height, plus this area, which is A into height, plus this area, which is half into B2, this length plus height, into height. Now here I can take half common, half and H common. What I'm left with is B1 plus 2 into H, half into H, 2 into A, sorry, A plus here half into H plus B2. So what I'm left with is half into H multiplied by B1 plus B2 plus A plus one extra A. Here I have 2A, right? So B1 plus B2 plus A. B1 plus B2 plus A is nothing but B. So it's half into, this part is B, the base one, plus A. I'm not sure if you guys were able to follow me because of the speed. I was rushing through it. But the clue here is simple. The clue here is simple. To find out the area of a trapezoid, we just broke it into three pieces, two right angle triangles on this side and then the rectangle, and found out the area of the three. And we just see 2a, I had here 2a, right? After we took out half h, this half h made it 2a. So 1a I combined with b1 plus b2 plus a, which gave me the bottom side, and then the one extra a is my top parallel line. So that is how it became half times h multiplied by b into a, b plus a. I hope I was able to explain this. If not, if there is any doubt, we'll certainly try clearing those doubts in the next class. A quick check before I